The broadcast is now starting. All attendees are in listen-only mode.
I would like to welcome everybody to this webinar on the latest issue of the safety law, which was published earlier in September. And it is about fertilizers, ammonium nitrate fertilizers incident. I hope that you can hear me well, and still people are coming to joining to the webinar, so I am going to wait a little bit, but at the same time I would like to just inform you that the next webinar on the safety law, and the next safety law will address mining accidents and especially methane explosion. And it will be really, really interesting, I believe so. My name is, for those who don't know me, Dr. Susanna Gyenes, and I am the deputy to the director of the iChemist Safety Center. It's been for a while now that the last webinar on the safety law was held. It's now the time for the next one. As I mentioned earlier, this is the safety law about key lessons from incidents related to ammonium nitrate fertilizers. Before I start the topic, I would like to kindly ask you, if you have any questions or comments, please add them to the question box, and I hope that I will be able to answer to those. But before that, I'd like to emphasize that this is a wide topic, and I'm pretty sure that you would have so many questions around the characteristics of ammonium nitrate, the storage environment and requirements of ammonium nitrate fertilizers, and so on. And therefore, we have already published and made available for free those loss prevention bulletin articles that I authored or co-authored with others, and we analyzed lessons learned from past incidents. Not only these two cases that I'm going to present today, but also others that happened in the past, and I think that they are so relevant. And I will tell you more about the aspects of those findings as well. The laws are all free to download from the iChemist website. You can find their iChemist and Safety Center. So I encourage you to share this knowledge, share this information if you find it important and useful for your operation, whatever your role is, and if you are interested. Right, now let's jump in. But first, I would like to give you a general overview about what we are talking about when we mention ammonium nitrate fertilizers. And as you can see here on the slide, ammonium nitrate's been involved in many past incidents that cause explosions, fires, toxic fume release, and it is known that even a really small scale storage of such ammonium nitrate fertilizer, for example 10 tons, in some legislation may place the population at really high risk. Now, ammonium nitrate has been in use since 1659, believe it or not, and it is a dual-use substance from which either fertilizers or explosives can be produced. It is produced at a large scale throughout the world, over 20 million tons, for instance, in 1998, with over a third of this production based in Europe, over 7 million tons. And it is without any doubt important for industrialized society. Even though pure ammonium nitrate is generally used safely, as we can see here in a couple of seconds on the slide, but still accidents occurring still in this world, as we could witness it when the Beirut explosion occurred earlier this year. I'm not going to go into the details, any details about the Beirut explosion in this webinar. Still the investigation is ongoing, and the safety law only emphasizes and researches those cases that are already closed. So that's just for clarification. And in this slide, I took it from LinkedIn. Actually, this is from The Economist. I used a similar sort of diagram in the loss prevention bulletin paper that you can download, as I mentioned earlier, to visualize all these big accidents. And I would like to highlight Opau and Texas City disaster, and especially Texas City disaster that occurred in 1947, where 2 ships were loaded with ammonium nitrate fertilizers, and then there were many different aspects with this accident, starting from noticing what is going on, and then not knowing about what was in the ship, meaning they didn't know about the characteristics, what the ammonium nitrate fertilizer is capable of, and how it is really destroying. And then about emergency response, that was another issue, and that people were gathering around because of the beautiful orange fume and sky, and so on and so forth. But all of these accidents, actually, primarily, I can tell that they occurred highly because of the fact that people were not aware of the hazards of ammonium nitrate fertilizers. And I will address other accidents as well, which is not on this particular diagram. And I will go now into the details about our case studies today. So the first case study that I'm going to address that occurred in 2013, April, there was a fire of undetermined origin that broke out at a storage facility. Approximately 30 tons of fertilizer-grade ammonium nitrate, which means with a 34% total nitrogen content, was stored in bulk granular form in a 7-meter-high bin inside a wooden warehouse. So you can already see some of the aspects of this accident that occurred, that there was a fertilizer-grade ammonium nitrate, and it was stored in warehouse and wooden warehouse. As a consequence of the explosion, the shockwave crushed buildings, flattened walls, and shattered windows. Unfortunately, 12 firefighters and emergency responders were killed in this accident, along with 3 members of the public who were also volunteer firefighters. That event also resulted, as you can see on the slide, in more than 260 injured victims, including other emergency responders and members to the public, and more than 150 buildings were damaged or got destroyed in the incident. That was a massive explosion, and it had such a devastating consequences and impacts on the local community, as you can imagine. Before I go into the lessons learned part, I would like to highlight that this particular case, actually I analyzed from 2 different perspectives. One was from the perspective of the hazard identification and lack of knowledge and everything around the characteristics of ammonium nitrate. But the other aspect that I really got into the details, and I analyzed it while I was still working for the Joint Research Center, the Major Accident Hazard Bureau, and published a lessons learned bulletin on emergency responders, because that is also important to mention, that how we can protect emergency responders in such cases so that they are aware what they are facing. Because in this case, and I will show you the key learning points, unfortunately, emergency responders, and not only this case, but also in Tianjin, firefighters didn't know about what was exactly stored in the warehouse. They knew about an ammonium tank that was stored in the facility, but they had no knowledge about the fertilizer-grade ammonium nitrate. Hence, they didn't know how to intervene. So it is really an utmost important that when emergency responders go into site and they try to intervene, then they need to know what are the hazards. So that can be done through like a preliminary, like a walk around in the facility and so on. So coming back to the case, the exact direct cause of the initial fire remains unknown. The only scenario which was considered as dangerous, as I mentioned, in the storage facility was the accidental release of anhydrous ammonia, as the company had the ammonia storage tank on site. And we can see this phenomenon in another case and potentially other more cases where the accident scenario that was considered was only this or only that, and it didn't include certain parameters, certain characteristics, and certain hazards. But that's just on the side note. Conducting comprehensive hazard identification, analysis, and risk assessment where hazardous substances are stored or handled is a basic requirement when operating dangerous establishments. For small and medium-sized enterprises may lack this expertise. Not all of them. I have to highlight that many small and medium-sized enterprises are really advanced and really good at in-process safety, but it can happen due to lack of resources. They don't have the same knowledge as, for instance, multinational companies have in place, but they may lack expertise, and in this particular case, stricter regulation should be applied and enforced. In Europe, the Seveso II directive actually got amended after the Toulouse accident in 2001 that addressed all sorts of ammonium nitrate and other types of fertilizers and how to handle them and what are the major hazards, and set up lower tier and upper tier thresholds for those substances. So that was regulated in Europe, and in this particular case, the investigation revealed that stricter regulation should be applied and enforced. What else? Separation of combustible materials from organic substances is needed to reduce potential conflagration and explosion once an ammonium nitrate fire is starting. When storing ammonium nitrate, in this case in bulk quantities, it's important to have proper fire prevention, protection, and mitigation measures in place. So even if someone decides to store ammonium nitrate fertilizer in the bulk storage, then at least these prevention, protection, and mitigation characteristics and measurements should be in place. And what else was important, as you can see here, the urban development. So land use planning has a really important aspect and role to play, because as I mentioned earlier, around 160 buildings got destroyed. In this particular, only one explosion, and I will show you soon the second case, but even more. And when you remember, and I won't mention again the Beirut explosions, but then you could see that also there the devastating effect of this explosion that left this after the accident, it's really significant. So land use planning is something that should be considered. Again, I can give the example of the Seveso directive and the COMA regulations, where it states really clearly the appropriate distance, safety distance from any operation. All right. So urban development around such dangerous sites that handle or store ammonium nitrate needs to be restricted, and in the case of existing development in close proximity to that particular site, appropriate prevention and protection measures should be in place to reduce the risk as much as it is possible. Now let's talk about the second case. on 21 of September in 2001, and normally I don't reveal which accident I'm talking about, but this one you will recognize because this is the Toulouse accident, and we have published a lot together with my French colleagues on the Toulouse accident, and this is a really significant, really complex one in Europe, and it had an overall effect on the amendment of the Seveso directive. So it played a really significant role. And also not only about the classification of dangerous substances and inclusion of more ammonium nitrate fertilizers and other fertilizers in the Annex 1 of the Seveso directive, but also the land use planning aspects. And I wanted to highlight this, even though this webinar is international, but I can give you this example based on the fact that it happened in Europe. So what happened here was a severe explosion that occurred in a chemical plant, and the detonation, as you can see, corresponded to a magnitude of 3.4 on the Richter scale. A 7-meter deep crater was observed outside the plant, and a large cloud of dust and red smoke drifted to the northwest. The accident, unfortunately, resulted in 30 fatalities with up to 10,000 people injured and 14,000 people suffering post-traumatic stress. The cost that was estimated to be in the range of 1.5 billion euros. The warehouse within the plant affected by the incident stored around 400 tons of downgraded off-specification ammonium nitrate-based products. The explosive properties of this varied as some were fertilizer grade and some were technical grade, which were dedicated to explosive purpose. Ammonium nitrate mixed with fuel oil. So what are the really major key learning points from this accident? Obviously, you will find more and more learning points from those publications, but I wanted to highlight some really significant ones for future relevance. So, as I mentioned, the direct cause of the explosion is not officially established. And this is really difficult. I mean, discovering and determining what was the direct cause in such devastating explosions. But the final legal expert report concluded that the explosion occurred due to an accidental combination of sodium dichloroisocyanurate and downgraded ammonium nitrate. It is assumed that waste containing chlorinated compounds manufactured in other unit of the plant was mixed by chance with waste from the ammonium nitrate-based materials. This error would have been committed by subcontractors in charge of waste management who lacked knowledge of hazards associated with ammonium nitrate-based materials. I'm just quoting here what the investigation revealed and what the legal experts said about it. We don't go into the details who was responsible, because that's not the main point and the learning point in such cases. The main learning points are what happened and why it happened. But then we can learn a lot from this aspect of how to work with subcontractors and what we should pay attention to when working with contract workers and subcontractors, so that they have an overall knowledge about the hazards associated with their activities. But first of all, I would like to highlight the other aspects. The investigation also revealed that the safety report of the factory, because it was a top-tier establishment, didn't take into account the off-specification and downgraded ammonium nitrate waste storage, since at that time it was not regulated. Although the explosion risk of ammonium nitrate was known, fire risk was considered more probable in open storage operations and as the reference scenario by the industry. I'm pretty sure that you remember other cases as well where a more severe or we can call also some of these as worst case scenarios were not considered for some reasons in different accidents. And one of them is, for instance, Buncefield, where the explosion risk was not considered, or it was considered low probability scenario. And so this happened in this case as well. What are the learning points from this particular case is that risk assessment should include all possible major accident scenarios, including the low probability, high consequence ones. Operators need full knowledge of the inherent hazards associated with the handling and the storage of ammonium nitrate fertilizers, and regularly review operating procedures to ensure they are being followed. The ammonium nitrate storage facility was not directly managed by the company employees, but by subcontractors. 25 subcontracting companies worked continuously on site, whose knowledge of the products and the site could have been incomplete. When contracting out a technical process to a third party, which happens really regularly in these years, the operator should ensure that all risks in the area and associated with the contractor's work have been identified and controlled. And of course, there was again this issue about urban development, so land use planning, where the establishment is within the residential area, how far public buildings are from or schools or hospitals and so on from the establishment. So those should be also regulated. I think that you can see now the similarities in between these two completely different accidents and those aspects that are really similar for both cases. As you remember, the safety law has a second part, and the second part is where I address the issue of what can I do. And this is a part to understand what you can do at your facility based on your role. And in the What Can I Do session that I will present you shortly, you can see how each of these elements plays a part. Very briefly, this is what you can see here is the iChemist Safety Center framework. It's not a process safety management system, doesn't seek to replace one, but this is how we believe that process safety outcomes are grouped together so that to achieve better results in process safety. So these are the elements such as systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And in the original document, in the PDF document of the safety law that is uploaded to our website, you will see that all key learning points are associated with these elements. So those are the colored dots in the beginning of each statement or recommendation. Now I won't visualize, excuse me, I won't visualize those here, but once you download the safety law PDF document, then you will see what I'm talking about. So first of all, let's see a couple of examples and recommendations what I can do as a manager. Mind you that I couldn't potentially highlight all aspects or all or all recommendations. Obviously, you can have much more, and I would be really happy if you could share them with me so that we can share with each other, because this is also a learning opportunity that we are here all together and discuss all these recommendations. So as a manager or as a management, make sure that all potential accident scenarios relating to ammonium nitrate fertilizers, based on state-of-the-art knowledge, are included in the risk assessment as well as in the emergency response plans. Remember that in the emergency response plans, you try to establish all potential accident scenarios, not only the high probability ones, but also trying to identify the worst case scenarios to be prepared for that kind of emergency. Ammonium nitrate may elevate combustion risks, follow established norms for mitigating fires, such as having a sprinkler system in place to minimize the risk of spread of a fire. Storage bunkers should be built at appropriate distances from each other, should you decide to store them in bulk storage facilities. Different classes of fertilizers should be stored according to the dangerous goods regulations and company policy. Make sure that written procedures for the handling and treatment of ammonium nitrate fertilizers are in place and that those procedures are really well communicated to both employees and contract workers. When storing ammonium nitrate fertilizers in bulk storage facilities or quantities, ensure you have proper fire prevention, protection, and mitigation measures in place. If possible, keep inventory to a minimum, and for larger inventory, keep them in bags. When storing ammonium nitrate fertilizers, avoid exposure to moisture or water to prevent caking, which can accelerate oxidization. It is recommended that plant or storage areas are constructed and maintained to avoid leaks, flooding, or any formation of pockets of moisture in areas where the ammonium nitrate is located. Now, if you are familiar with what happened in Opau in 1921, then you will understand what I'm talking about when I mention caking. I highly recommend to read that accident. I know that sometimes I refer to accidents that occurred in a really past. I mean, and you may think that, yeah, but the technology has evolved and we are now really advanced in this or that, but yet we're still witnessing such really big accidents. Then I would question or at least I would just come back to these past incidents and pick up those stories and read about them and try to identify those aspects that are still similar. I mean, ammonium nitrate fertilizer is still caking. And so that's why we can learn a lot even from those even from those accidents that occurred even like 100 years ago. Why not? I highly encourage to read those past accidents. What else? Hazard identification should include the sensitivity of ammonium nitrate to changes in operating conditions. Over the life of the plant, unintended events could adversely affect storage conditions and need to be addressed in order to establish appropriate safety controls and procedures. And this particular recommendation is really related to the phenomenon that I discussed in other webinars and other safety law on creeping changes. So even the most subtle change in the system, in the operating conditions, change in the change in the, can you hear me? No, you can't. Can you? Hopefully you can. Sorry, it said that I lost my audio, but I hope that you can hear me. Just give me a yes or no, please, in the question box if you can. So this is what you can do as a management. Apologies for this short break. For some reason I lost I lost internet connection. I hope that you are still here. and can hear me, and I'm losing my voice as well. All right. What can you do as a process engineer or supervisor in this particular case? So, ensure that both employees and contract workers possess adequate knowledge of the inherent hazards of ammonium nitrate fertilizers and regularly review operating procedures to ensure they are correct and they are being followed. For indoor storage, make sure that the storage area is not congested and that proper ventilation is available, as it limits the progress of decomposition should it occur. Make sure that off-specification and downgraded or technical grade ammonium nitrate fertilizers are separated from any contaminants, for example, organic materials prone to increase the explosion hazard of ammonium nitrate. Handle off-specification, downgraded or technical grade fertilizer contaminated with organic material safely and segregate them from other products. Fire protection strategies should be based on minimizing the presence, both potential and actual, of combustibles. And try to make sure that plant and floors for storage area are kept clean, avoiding the accumulation of deposits of fertilizers materials. Good housekeeping is essential to prevent certain issues, but that is applied to any sort of storage facilities or any sort of facilities around the world. Now, what can you do as an operator, which is the last part of this safety law? As an operator, make sure that you have full knowledge of the inherent hazards associated with the handling and storage of ammonium nitrate fertilizer and ensure that you follow operating procedures. Minimize the presence of combustible materials and incompatible substances, for example, explosives, near ammonium nitrate. Be aware of and follow appropriate safety precautions associated with ammonium nitrate fertilizer storage, including packaging and packaging stacking, temperature, and other elements. Control ignition sources, which means, for example, hot work, smoking, vehicles. One aspect with regards to the Texas City disaster in 1947, that was the smoldering that started the fire within one of the ships, was due to a cigarette. So that was thrown to this bulk stored ammonium nitrate. With control of the electrical system in the storage. Clear spillage up promptly and put damaged bags into overpacks, using a secondary bag of sound construction that will prevent further spillage. Equipment used in the handling of ammonium nitrate, such as conveyor belts, should be made of material that doesn't readily ignite or burn. Now, I'm pretty sure that you have more recommendations and more tips for handling, storing ammonium nitrate fertilizers, and there are so many really good different sources of information and guidance documents available online. I highly encourage you, if you have to either handle, store, manufacture, or regulate or inspect such warehouses, hazardous establishments, then I would highly recommend you to read as much as possible about these guidance documents about how to handle ammonium nitrate, because this list is not complete, obviously, but it gives some hints in terms of how to avoid future occurrence of such accidents. And I hope that you didn't miss when I lost internet connection for a couple of seconds. Apologies for that. And if you want to learn more about the safety law, here you can see that we have published a podcast that is available to download. One other thing I wanted to mention is that there is the English version of the safety law available already, and we are going to upload the Spanish version very, very soon as well, like we do it all the time with all the safety laws. So you can get the information about those as well. And here you can find my contact details if you want to send further questions or comments. Now I'm up for questions. I'm not sure if I can answer very, very detailed questions about the physics and characteristics and really detailed information about ammonium nitrate fertilizers, but I try my best because these publications are in general covering topics. So yes, there is a recommendation here that the material safety data sheet of the chemical shall be made available to all concerned. That is a really good one. Thank you so much for that comment. I highly agree with that, and that is applied in every case, every storage facilities, that the material safety data sheet should be available. If you don't have any other questions, yes, there is another comment. Training on behavior-based safety shall be implemented to working in the area. Yes, yes, absolutely. Thank you so much. I can't see any more questions, so I would like to thank you so much for your kind participation, and the safety law webinar will be uploaded to both the iChemist Safety Center YouTube channel, and I will publish it on LinkedIn, and you can see here all the forums where you can find us. And if you have any further questions or suggestions, then please send them to us using email or any other of those forums. And thank you so much. Thank you, Norway. And thank you all of you who came today. I really appreciate, and have a good evening, have a good day, and wherever you are based. So thank you, and stay safe. Thank you. Bye-bye. And Scotland. Yes, thank you.